So when we had left off, we had just finished doing, at first, a right rectangular approximation method, which gave us an overestimate. Then we did a left, which gave us an underestimate. And now to even be more accurate, what we're going to do here is we're going to do a midpoint rectangular approximation method. And you'll see we even get a little closer. And for the midpoint one, instead of saying, all right, we're going to start our rectangles and hit on the left, go over, go up and hit on the left and go over. This is how we draw our left endpoint approximations. When we do our right ones, we say let's start on the right, hit and go over. And start on the right, hit and go over. Instead of that, what we're going to do to try to increase our accuracy, make our approximation a little better, is we're going to go into the middle of the interval, go up, hit, and we're going to draw a rectangle like that. So what I'd like you to do here, we're going to go up, hit, go down, go to the middle, go up, hit, go down, and I'm getting a little sloppy here, sorry. I'm going to go up, hit, and go down. And you can see why this is going to give us a little bit better approximation, because what we seem to be missing of the green, we seem to be making up with the white. So what we're going to do here is we are going to go use this same thought process that we did with the other ones. We are going to have, again, because we're choosing our n to be 4, which is making my delta x equal to a half, what I've got here is 1, again 2, and 3, 4 rectangles. To calculate the area, I do them each individually. I say the area of the total would be the area of the first one, second, third, fourth. Each rectangle's area can be found by doing base times height. The base of each one is still the same. The delta x is still a half. So for each one of these, I'm going to be doing a half times the height. Base times height. Base times height. Base times height. The difference is now I'm hitting the curve in the middle. So my height is in the middle. It's not f of 0 if I were to the left or f of a half if I were to the right. It's f of 0.25 right in the middle. And this is f of 0.75, f of 1.25, f of 1.75. That's where I'm hitting the curve in the middle. So we go put it in the middle and we go, sorry, that's f of 0.25, f of 0.75, the height of the function at 1.25, and the height of the function at 1.75. I can go get those off my table by doing, again, the ask. Just make sure that under your y equals, you have an x squared plus 1. Go to the table, have it set for ask, and just enter those, and you'll be able to pluck those off as decimals. Or this one's easy enough, you could put it in the original and keep them as fractions. But if you go do that, you end up getting about 4.6. I'm not going to go do all the calculation. I think it's about 4.626, just trust me. Here's the exact area. Well, how did they come up with the exact? We're spending all this time on approximation. How did they just say, for comparison's sake, that's the exact area? Well, that's what we're leading up to. I can tell you that I was able to get my calculator to do it. I'm not going to tell you how right now. But I got the exact area under the curve right here. It says 4.666667. It has to round at the end, but I got it basically to give me the decimal value of 14 thirds. But where did this 14 thirds come from? Well, that's coming up in a few days. That's going to be how we tie in this area concept with our integration. Right now they seem very separate. We're just taking a bunch of integrals, and now all of a sudden I'm doing area of rectangles. It seems very disjointed, but they're going to tie in eventually so that we no longer have to approximate. We'll be able to get an exact area. But for now, we're doing approximations, and we're going to have overestimates. We had an overestimate of 5 point something, I don't remember, back on the other page when we did our RAM. We had an underestimate of 3.75 with our LRAM, but when we did the midpoint one, we were really close. Well, then it becomes the question, could I make it even better? Could I have gotten all of them to even be more close to the actual value? And the answer is yeah, there's a couple ways you could do that. One obvious way is just to make more rectangles. We could make more rectangles. Actually, we could make them and have n approach infinity and have just them be so tiny that when I shade them in, it doesn't matter if I'm going to the left or to the right, because when I shade in all these super, super tiny rectangles, rectangles, I'm getting the area under the curve. That's going to tie into integration pretty soon. So your worksheet says that, another thing we could do to make it, for now, even more accurate is instead of doing rectangles, we could do trapezoids. Because you can see those are going to be even a little bit better, and we do that tomorrow. But for your first worksheet, you're going to do those 5 problems on that half slip that I gave you. And what I want to do is I'm going to run through one like it. So it says to see a sample on the back. And we're going to put this one on the back so you can see what I want you to do. I'm going to keep it really similar to the third one down where it says the square root of x plus 3. I'm actually going to keep that function for my sample. So again, this is a sample. I want you to put it on the back of the half slip so you know what your work's supposed to look like. I'm going to change the interval from -2 to 6. I'm going to change the LRAM to an RRAM for my sample, just to shake it up a little bit. I'll keep delta x at 2. And I don't know what my solution is yet because I haven't done it. Alright, so if you look at the bullets, it says, first thing I want for each of these is a sketch of the curve. So we're going to go sketch the square root of x plus 3 on this interval. You're going to provide me with a good sketch. If you need your calculator to help you with that, go ahead. So we're going to go from -2 to 6, and we're going to graph the square root of x plus 3. When you put in a -2, it'll be up at 1. When you put in a 6, it'll be up at 3. I'm going to just do a rough sketch of the curve. My goal is to estimate the area under this curve by using right rectangles. So what I want you to go do next is draw those rectangles, and I'm going to do it in green like it was in notes. If we're doing a right approximation method, and notice it says delta x is 2, so we're doing this every 2. So 1, 2, 1, 2, 1, 2, 1, 2. So we're splitting our x-axis, or a change in x, up into 2. Keep in mind, this one I didn't tell you how many rectangles. So you've got to kind of say, well, if my interval is 8 long, and I want the delta x to be 2, I'm going to have to divide it into 4 rectangles. So I will be making 4 rectangles, and because it says a right rectangular approximation, I'm going to head right up, hit it on the right, go over. I'm going to head right up, hit it on the right, go over. I'm going to continue that right to, where's my last one? Here. So I'm hitting the curve on the right of it. You'll notice my original blue curve wasn't so great, but you can see that I'm going to have an overestimate. Well, how did I kind of know I was going to have that? This is a right rectangular method. It's increasing, so I will get an overestimate. Just remember that word real. So I've got, and I want you to go label them, 1, 2, 3, 4 rectangles. And I want you to bold in these places where it's hitting the curve. Notice I'm not using this first endpoint. And I keep stressing that because when they give it to you on a table without a function, you're going to have to kind of keep in mind that when you're doing a right rectangular method, you stick to the right, and you actually don't use the leftmost endpoint. So this is the work I need you to show me. It says sketch it, did. It says divide it into n rectangles. I did that. All right. My n is b minus a over delta x, which is good. It says shade and label. I don't want to shade on the smartboard, but I've labeled them all A1, A2, A3, and A4. So I've got my total area. It's going to equal area 1 plus area 2 plus area 3 plus area 4. All right? For each of these, the area is the base times the height. Your base is delta x. So for each one, it's going to be 2 times the height plus 2 times the height plus 2 times the height plus 2 times the height. Well, for the first one, the height is right here. That's f of 0. Notice I didn't use the leftmost endpoint because I'm sticking to the right. So I'm going to be doing 0, 2, 4, 6 versus the left RAM. 0, 2, 4, 6. For LRAM, you'd do -2, 0, 2, 4. You'd stick to the left and not be using this endpoint. So for this one, I really can stay off my calculator for a bit because I'm going to be doing f of 0, f of 2, f of 4, and the height at 6. Those are the heights at each of my 4 bolded dots. And my function is the square root of x plus 3. So this would be 2 times the square root of 0 plus 3. This would be the 2 times the square root of 2 plus 3. This would be 2 times the square root of, what am I at, 4 plus 3. And this would be 2 times the square root of 9 plus 3. Or 6 plus 3, which is the square root of 9. And that's going to be nice. Could make that a 3 if I wanted to. Then what you're going to do is you're going to go to your calculator and you can go ahead and round that answer to 3 decimal places. I don't have my calculator out. Now, if you notice in there, it says you can use your calculator and you can use it for the table if you want for some of the other ones where you need the table to calculate these. Notice in the book that right here, what they call all this is the sum of the change in x, the bases, that's all these, times the height, which is f of x sub I, your first one, second one, third one, fourth one. That's what you're really doing here in terms of notation. And if you wanted to, you could have pulled this 2 out, but it's not really necessary, and I wouldn't right now, because for the AP exam, they mess with these intervals down here, and they don't keep them all the same. We'll practice that in a day or two. So that's the steps that you need to show me. Again, you need to sketch it out. You need to draw your rectangles. You need to shade them in. You need to bold the dots either to the right if it's RRAM, to the left if it's an LRAM, in the middle if it's an MRAM. I put all the answers on there so you should know if you're doing them right. You guys have a great day. I am done.